Hello and welcome to today's lesson on mass and weight, which is part of the forces topic in GCSE Combined Science. So in today's lesson we're going to look at the difference between mass and weight. So if we've been successful and learnt in today's lesson, we should be able to define weight and mass and explain the difference between them, calculate the weight of an object on Earth using W equals mg, give the correct units of weight and mass, and describe the relationship between weight and mass and what would happen to weight if mass was doubled. Now, mass is a measure of the matter found in an object. So mass is the amount of matter in an object. It's the scientific measure of how many particle matter there is in an object. Now, the scientific standard unit of mass is the kilogram. Now, mass is a scalar, which means it has no direction attached to it. So the mass of an object remains unchanged in the universe unless you alter what the object is made from. This means that mass is independent of any other factor in the universe. Now, it's important to note that mass is a base value of the universe. So to make the concept simpler, we assume all of the mass of an object is found at the center of mass of an object. Now, weight is the force acting on the mass due to gravity. So weight is caused by an object being in a gravitational field. So when you are on the Earth's gravitational field causes you to have weight. This means both mass and gravitational field strength affect the weight. Now, weight is always assumed to act from the center of mass of the object. So in force diagrams, you should draw all forces from the center of mass of the object. So this means the weight can change depending on the gravitational field you are in. The larger the planet or star, the larger the gravitational field, the larger the weight found there. So as we know, force is a vector. So weight is a force, making it a vector. Now, weight always acts towards the center of the gravitational field, and we interpret this on Earth as downwards. Now, the scientific standard unit of weight is the Newton. Now, weight is caused by a mass. So this means the weight and mass are directly proportional to each other. So when mass doubles, weight doubles. When mass triples, weight triples. When mass halves, weight halves. So as weight and mass are directly proportional to each other, a graph of the two factors would look like the following. So when two factors are directly proportional to each other, the line of best fit produced is a straight line through the origin. Now, as the weight is caused by mass, we also say that weight is said to act from the center of mass because all of the mass is assumed to be at this point. Now, the weight of an object is measured with a spring balance that considers the force applied by a mass, which we call a Newton meter. So mass is a measure of the matter in a substance. Mass is a scalar measured in kilograms, and it's an unchanging value in the universe. Weight is the force of gravity acting on mass caused by the mass being in a gravitational field, and weight is a vector measured in newtons. So weight depends on the gravitational field strength. Now, mass and weight are directly proportional to each other. So weight is a force due to both the mass of the object and the gravitational field it is in. This means to calculate the weight, we've got to consider both factors. So weight is equal to mass times by gravitational field strength. Now, you've got to memorize the value of gravitational field strength on Earth, which is 9.81 meters per second squared, which is sometimes simplified to 10 meters per second squared. Now, this equation must be memorized for your GCSE physics examinations. Now, if this G value is the same G as the one found in the equation, a gravitational potential energy is equal to mass times by G times by the change in height. So let's just clarify this again. Weight is a force caused by both the mass of an object and the gravitational field it is in. Weight in newtons is equal to mass in kilograms times by the gravitational field strength in either newtons per kilogram or meters per second squared. Now, the strength of gravity on Earth is 9.81 meters per second squared. So here's an example calculation. The mass of an average train is 25,000 kilograms. What is the weight of the train on Earth? So weight is equal to mass times by gravitational field strength. So it's 25,000 times by 9.81. So that gives you a value of 245,250. So you get an answer of 250000 newtons. We've got our answer to the correct number of significant figures and a unit. So to summarise what we've learned in today's lesson, weight is the force acting on an object due to gravity. The force of gravity close to Earth is due to the gravitational field around the Earth. The weight of an object depends on the gravitational field strength at the point where the object is. So the weight of an object can be calculated with the equation weight is equal to mass times by gravitational field strength. The weight of an object may be considered to act from a single point, referred to as the object's centre of mass. The weight of an object and the mass of an object are directly proportional, and weight is measured using a calibrated spring balance, a Newton meter. So if we've been successful and learnt in today's lesson, we should be able to define weight and mass and explain the difference between them, calculate the weight of an object on Earth using W equals mg, give the correct units of weight and mass, and describe the relationship between weight and mass and what would happen to weight if mass was doubled. So thank you very much for watching this video on mass and weight, which is part of the forces topic in GCSE Combined Science Physics. Thank you very much for watching and have a lovely day.